Unlock your potential today at skillbakery.com.
Welcome to another exciting video. Now here, what we have done till now is that we have explored the main method and it was kind of returning either the result or a specific error. But consider a scenario where a method can return more than one kind of error or one type of error. So to handle such scenarios, we have the box type in Rust. So here you can see that when we are writing it in this way, box dynamic error, and then we are saying that it's going to handle errors. So it's a type in Rust which represents a way to handle errors in a flexible and dynamic manner. It allows different kind of errors to be returned under a common type. So if we go ahead and break this statement down, like we have the box over here. So box is basically a smart pointer for heap allocation. So in this case, box dynamic error allocates the error dynamically on the heap, and the box itself is a pointer to that error. Heap allocation is useful when the exact size of the value isn't known at compile time, such as when working with trait objects, like over here we have dynamic error. Then we have this dynamic dispatch, the keyword dyn. The dyn is basically a short for dynamic dispatch, which is used when you don't know the exact type of an object at compile time, but you do know that it implements a particular trait. In this case, dynamic dispatch error means a type that implements the error trait, but one does not know which one at compile time. This allows for polymorphism, which means multiple types of error that implement this error can be treated the same way. Then we have the error trait over here. Now the error trait is a trait in Rust's standard library that represents an error. It requires that the error type provides two key pieces of information. One is the description, which is a human readable description of the error, and then other one is the source, which is optional, and this basically captures what caused the error, allowing the error chaining. So the error trait is implemented by many standard library types like input-output error, format error, and custom errors. When we put it all together, we have this statement box dynamic error, which means a heap allocated object of some type that implements the error trait. This allows a function to return a different type of errors while still using a single return type. Since the exact error type isn't known at compile time, we use the dynamic dispatch and heap allocation, that's box, to manage this flexibility. Now let's go ahead and explore this via an example. So what we'll do is we'll create a method. Let's call that method as read and validate. So we will be required to make sure that we have the standard input output and standard error included. So here we'll first of all check that, and you can see we have the standard input output, but the user standard error is not there. So let's include that. Once we have it, we will be creating our function read and validate, and in this function we can write it over here, and you can see that it's going to return a positive non-zero integer, which we'll be defining, and then a dynamic error type. So basically we are reading the input from the standard input. So this could return into some kind of error. So you can see we are making use of the question mark operator over here. So that's one error that will be returned. And then we are parsing the entered data. And if it's going to be an integer, then fine. Otherwise, again, we are using the question mark symbol to throw the error. And finally, we have this positive non-zero integer. Now, positive non-zero integer is going to be a struct type. So we will be creating that as well real quick, just below this method definition. So here, let's go ahead and implement that as well. Struct positive non-zero integer. And this is going to implement this positive non-zero integer definition, and you can see that we are returning a result where it's returning self, otherwise an error will be of type string. So here if the value is greater than 0, we are saying That's the positive non-zero integer. Otherwise, we are simply making use of the error block, and we are saying is not a positive non-zero integer. Now also, we need to display it. So for that, we will be implementing the display for positive non-zero integer, and that we can do just down below this method definition, or just down below this struct definition. Basically, we are implementing the display trait for the positive non-zero integer struct in Rust. Now, the display trait defines how a type should be formatted when used with the curly brackets, and that's the format specifier in Rust string formatting macros like println or format. So here, using the impl block, we are simply implementing the display trait for the positive non-zero integer struct. And when we are saying std format display, which is the fully qualified name for the display trait, and it kind of lives in the standard FMT, and we have to make it this way because we have not included it in our use statement. Now, the format method is the only method required to implement the display trait. It tells Rust how to format an instance of your type. And if you notice, it has got certain parameters like self, which is a reference to the current instance of positive non-zero integer that you want to format. And then we have the next set of parameter over here, which is a mutable reference to a formatter, which is responsible for writing the formatted output. Now, the underscore that you see over here is the lifetime annotation. It indicates that the reference is borrowing for the duration of the function. And then we have the return type over here. Now, the return type, which is a result, indicates that formatting can either succeed, which will return OK, or fail, return formatting error. And then we have the formatting logic, where we are using the write macro and writing to the provided formatter, which is f in this case. Now that we have implemented our struct and implemented our read and validate method, it's time now to use this method and call it in our main function. If you go down below, here we have our main function. Earlier, it was returning this result with a unit as the success and parseInt error as the error. So what we'll do now is we'll be updating this main method. Let's go ahead and do that real quick. So here in our main method, the first thing that we need to change is the return type. So instead of this return type, we'll now have the box dynamic return type. And you will notice that the result success is still unit type, but the error is now updated to box dynamic type. And here, let's comment this piece of code and write our main function implementation after this. So here, we'll be simply writing this, that is match, read, and validate. If the value provided by the user is proper, then we will be simply making use of the println macro, where we'll say valid positive integer, and then we'll print that value. Otherwise, the error that will come up will be handled. And here we'll be making use of eprintln. We'll come to that as well, what exactly it is and how it is different from println. So here we have our main method implementation for it. Let's save this and now understand what's the difference between println and eprintln. So with println, it sends the output to standard out, which is generally used for regular program output like results or information. With eprintln, it sends to std error, which is conventionally used for error messages and diagnostics. So here, if I just mention it as a comment, it prints over here std out, and this goes to std error. Now, why do we need to make use of std error for errors? So first thing is because it allows us to separating logs from errors. By printing error messages to std err, you separate normal program output to std out, and the error and diagnostic information goes to std err. And the next thing is error handling pipelines. So when running scripts or programs in a pipeline, having errors sent to stderr prevents them from being mixed with the regular output, which is important for logging or training commands. The third thing is, it has got this debugging and clarity. So by using eprintln, you're clearly indicating that something went wrong and signaling the error channel. So over here, if I run it using the cargo run, and then I also specify this output.txt. So here, the program's standard output, including both normal messages and errors, will be redirected to output.txt. This can make it harder to distinguish between successful outputs and errors. Now, if we make use of eprintln, in this case, normal messages go to output.txt, but errors still appear in the terminal, making it easier to spot them. So now, let's save this file and run it to see it in action. So here I'm entering hello, which is obviously not a number at all. Let's press enter now. And here you can see it says that invalid digit found in the string. So this is the error that is coming up. Now if I go ahead and run cargo run with the same set of commands like output.txt, and here this time around I enter -1, which is a not positive number. So here you can see the error is now coming up as -1 is not a positive non-zero integer. Let's go back and run it one more time, and this time around I'll be entering a number, +1, 10. This time you will see that output is not shown over here. So where exactly is the output? Here you can see that the output.txt file is created, and within that you get the output coming up using the println macro that we had. If we do not specify the output text file, obviously the terminal will be the place where both the error as well as the println output will be shown. So in this one, we covered a couple of things like how to handle dynamic errors, println, and also the difference between println and eprintln and why we should be using them. If you find the video helpful, don't forget to like and subscribe.